Ben Wycliffe here. I'm going to be doing a paper review for the paper titled A Systematic Review of Human-Computer Interaction and Explainable Artificial Intelligence in Healthcare with Artificial Intelligence Techniques. So the background of this paper, we're looking at HCI as a human-computer interaction as a multidiscipline field which aims to improve the interaction between users and computing devices. So the two multidisciplines are technology and psychology. So technology supports easy structure of communication, while psychology focuses on a general framework for interaction of human beings with systems and software. So HCI and AI work hand in hand, and this happens in such a way that AI mimics human beings to build intelligent systems, while HCI attempts to understand human beings to adapt to machines to improve safety, efficiency, and also the user experience. So the research goals in this paper were to identify problems in human-computer interactions and review machine learning characteristics, looking at the different techniques of explainable artificial intelligence, and also identifying problems and challenges with explainable AI, and then reviewing the explainable artificial intelligence in healthcare, and also challenges of explainable AI in healthcare still. So this research was just a review really, and this is the keywords that they used to retrieve their data or papers were these. They were restricted to these, and these were the sources. So those were the statistics of the papers they managed to acquire from the different sources. So they deduce HCI, that HCI can be further represented into two main categories, and these have corresponding problems. So the first category is human-centered design, and the challenge with the human-centered design includes sometimes unclear requirements and wrong design solutions, or unclear context of usage. So these challenges in HCI can be, this HCD challenge can be addressed by taking clear requirements from the client, and also involving the client from the beginning of the implementation through the entire process. And then usability is another one, and this is concerned with issues related to interfaces. But the problem here is really just efficiency in the interfaces. But there are some mathematical methods of checking usability of interfaces, so the designers can go ahead and test that. The ML characteristics they managed to pile up through their literature review included the fact that ML is accountable, and so the accountable characteristic is concerned with the consequences related to any event occurring, though sometimes a system cannot be held accountable for all actions. AI or machine learning can sometimes be involved in taking accountable actions or decisions. Then AI can be autonomous, so this is related to autonomous sensing and decision making in a dynamic environment. And then fairness, so AI should always strive to ensure that individuals are treated equally based on that they are not treated based on their race or gender or disabilities. And then transparency, which sort of provides the end user with information on how the model works. And then trustworthy, which provides safety to the user, giving them confidence to use the system without any concerns. And then privacy, which is concerned with prevention from unauthorized use of services. And lastly, explainability, what we are looking at here, and it provides the end user with information on why the model is working in a particular way. So this is the main characteristic, and it combines concepts from HCI and artificial intelligence. So a little more on explainable AI. This emerged through the third wave of AI, which introduced several other trends, including human-centered AI, which sort of focuses on the idea of using AI to enhance humans rather than replacing them. And then useful and usable AI, which focuses on creating solutions that are easy to learn and use through optimal user experiences created by effective human-computer interaction design. And then lastly, our explainable AI here, which should enable users to understand algorithms and parameters used to address the AI black box problem. So without explainable AI, we have a black box, and we have some questions that are left unanswered, like why did the model do what it did? Why did it provide that particular result? When does it succeed or fail? And when we can put trust in the model. Explainable AI has 3 steps according to the review in this paper, and this is on an organizational level. So if you're doing explainable AI on an organization level, you'll start by with the first step, which is explainable building process, and this involves assembling a team of experts who are knowledgeable with artificial intelligence and explainable AI, and then focus on in parallel focus on the visualization techniques, which would aid interpretation of the output against the context variable to give like a feel of how the model is doing, and then discussion about the tools to use. For example, shall we be using TensorFlow, PyTorch, or scikit-learn, things like that. And then next, after that, you do the explainable decision. So this involves explaining every decision taken by your system, and this is where you can have algorithms such as tree interpreter, lime, and sharp helping with the explanation of your AI's decision. And then the last part of explainable AI development is enabling interoperability of these AI systems with each other, and also integrating with other software systems that may be involved with business. So they went ahead and pointed out the properties of explainability, and these include it should be social in terms of being able to model explanations of the to the interpreter, and then it should be selective in terms of like selecting appropriate explanations related to the different hypotheses, and then it should be contrastive in terms of being able to differentiate between the different hypotheses, and then it should be local in a sense that you should be able to evaluate a particular decision. So if your model has like a number of inputs, you should be able to look at a particular a decision on a particular input. That's in case you have multiple inputs. And then it should be global in terms of like explaining the entire model, like looking at the complete model and coming up with an explanation to it. And then the other property is abstraction. When you have like complex models, you should be able to simplify the explainable model and provide useful feedback. So the types of explainability they pointed out from the review were plan-based. So this is when you have like a plan, and then you set out to explain that plan based on a set of observations from your model. And then there is model-based explanations, which involves understanding why a system performs in a particular way, and this involves a lot of engagement from the user, and it's largely to some extent involves a mental model for designing the system. So it involves a bit of cognition from the user. And then there is algorithm-based explainability, where you have a specific algorithm being utilized to explain your model. So these are the goals of AI. So they include goals of explainable AI. So they include trustworthiness, causality, transferability. So it should be transferable to different domains. Informativeness should be giving us important information. Confidence, it should be giving us confidence in the algorithm. Fairness, shouldn't be biased in terms of gender or race or whatsoever. Accessibility, interactivity in terms of it should understandably provide information to the end user. And then privacy awareness, so it should try to avoid any breaches of privacy. So some of the explainability techniques they encountered in their literature. So these were techniques they So they were reviewing a bunch of papers, and these papers were suggesting a number of novel approaches. So they were getting these novel approaches and associating them with a particular category. So the first one was the text-based explainability, and this involves an explainable model that generates text explanations for your results. So this can be, according to the literature, it works in both NLP and computer vision domains. And the idea is explanations are derived from your input data. So an example that appeared in the literature used a dual attention-based neural network. It was sort of trying to address the issue of unexplained stock prediction. So on top of having a stock prediction data, they had some news language data. So they used that data with the attention-based neural network to create a model that produced explanations for the stock predictions. And then other researchers proposed text-based explainability with a method called predictive coding, which seems quite new. And then another type of technique include the local explanation. And this again sort of is used to express like an individual feature for a particular instance. So it's sort of like explaining individual decisions made by a classifier. Think of it like you have a classifier that takes in multiple inputs, and then you need to be able to come up with an explanation for how the classifier makes a decision on every input. So that's the local explanation. And then the global explanation, it attempts to come up with an explanation for the entire model. And then visual explanations attempts to provide visual representations of the behavior of the model, and these are particularly common in the field of deep learning. And then explanation by example, this involves extraction of data in terms of the features formed as the model learns, and it generally just involves better understanding the model itself. And then there is explanation by simplification. So this is when you have like a more complex model. So the whole system is sort of like rebuilt based on a trained model, and then that way they are able to explain it, sort of like reverse engineering. And then feature relevance. This happens after the model has been trained. So it attempts to come up with an explanation for the internal functioning of a system by defining how it affects the different decisions, or pointing out how each feature affects the decision. And then there is provenance-based ones, which are used for explaining by illustrating some or all of the prediction derivative processes. This is largely intuitive, and it's also considered to be an effective usability technique. Then there is a surrogate model where you use other models as a proxy for explaining your model. So an example that appeared in their review was Lime, which learns surrogates using an operation called input perturbation. And then there is declarative induction, and this involves usage of human readable representation. So you sort of come up with these representations that may appear in form of rules, certain rules, or maybe trees or sets, or a text-based explanation. And then lastly, there is the rule-based techniques, and these involve like creation of a set of rules that are matched with the result of the model, and that way the explanation for the performance of your model is generated. So some challenges of healthcare in AI included organizational issues and communication issues that may probably arise as information is lost as it's being transferred from the user of a patient to the AI, and then social relations in the context of the healthcare system. And then there's a big problem with transparency. It's sort of quite difficult to understand what exactly is going on with the models. And then restrictions in terms of what AI models you can choose to use. And then the explainability is still an issue. The techniques are not quite easy to understand. And then interpretability, sometimes it's quite difficult to come up with a sufficient interpretation. And then there are issues with robustness, so it needs more features in terms of data to be added onto the current data sets to improve the performance. And then explainability is still a big issue again. Accuracy needs to be improved. There's false causation. Sometimes the explanation shows wrong causations or causations that do not make sense. The explainability is still largely lacking and insufficient to a certain extent. And then the complexity is also an issue. Some of the explainable AI approaches are quite complex to integrate in the existing models. And then lack of explainable operations and a lack of high level of explainability. So these are the challenges they managed to list out from all the papers they reviewed on a high level. So some of the possible solutions they suggested included improvement of abstraction and lack of explainability of models by including feature importance, which would help in prediction of classification of ML models, and also developing more transparent models for major diseases such as diabetes and cancer, and then equipping doctors and health professionals with basic AI knowledge. This way it would be easier to achieve transparency, as these professions will be in better position to come up with more sophisticated interpretation, probably, of causations or model explanations. And then some of the gaps to be addressed that they pointed out include the development of explainable AI models capable of methods that should be useful for the end users and clinical experts in the medical domain. And then there's still a huge gap in terms of developing interfaces for explainable AI in medical domains. And then there's a gap of model agnostic AI models. This is an open area for research. And then transparency still remains an issue, as we've seen as we are going through a high-level list of challenges. So the limitation of this research, so it was based on a small number of resources, and also the number of strings and keywords were restricted, so that means there is probably a lot of other useful information that was not captured in this review. And also the study really focuses on fundamentals. For example, we've seen in terms of the explainable techniques, we don't really look at the state of the art, but rather some of the novel approaches that were suggested by some of the papers without necessarily digging deep into how exactly that was done. So in conclusion, the study does successfully present a comprehensive review of explainable AI, and it does dive into human-computer interaction, artificial intelligence, and explainable AI, and furthermore reviews the impact of these in healthcare. So the study points out enhancement and addition of new explainability approaches linked to certain domains, and on top of that, improving interpretability and accuracy concerns as things that should be given the highest priority in the future. Thank you.